In this section, I want to talk about different notations in binary, in decimal, and in hexadecimal, and I want to show you some methods to convert numbers between these three formats. First of all, you should know that we have different digits in each of these. For binary, we have only 0 and 1. So a bit in binary can have only a value of 0 or 1. What about the decimal? In decimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we can use these different digits to create numbers in decimal. What about hexadecimal? In hexadecimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So you can see that because we cannot use two different digits to show these numbers, we use letters to show them. So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So how can I convert between these two numbers? How can I use these digits to show a number? If I want to show a number using binary notation, I just combine different bits together. For example, this is 0, 1, 1, 1, 0, 0, 1, 0, 0, 1. So this is a number in binary. And I can use that in computer world. Of course, this is the main way to show the different numbers or values. What about decimals? We use different digits in decimal. For example, this is 1, 2, 5, 8, 9. This is a number in decimal. What about hexadecimal? I can use, for example, 1, 1, A, B, 9, 1, and this is a number in decimal. How can I convert these numbers to each other? How can I know that what is the meaning of this number in decimal or hexadecimal, or what about the other one? I want to show you different methods to do this. First of all, let's go for binary. And binary is very easy to learn. When we are talking about IP addresses, we talk about only 32 bits. So we are not going to have more than 32 bits. And because 32 bits is very hard to work with, we divide this into 4 different portions. Each portion has only 8 bits. So let me show you 8 placeholders for 8 bits. This is the first, second, third, fourth, fifth, sixth, seventh, and 8th placeholder. So we have 8 bits, and we call this an octet, and we have 4 octets in an IP address. So we have 32 bits in an IP address. So if I want to convert this, instead of using normal methods, I go for a very simpler method. A much simpler method is to give values to these different placeholders. And I want to write these values using, for example, blue color. Let me write this. From left to right, we have this. Remember all of these numbers. That's because this is very, very useful. And it is not too much to remember. The first one from the left has a value of 128. So this is bit 1. Remember that? From left to right, this is bit 1, and it has a value of 128. Bit 2 has a value of 64. Bit 3 has a value of 32. Bit 4 has a value of 16. Bit 5 has a value of 8. Bit 6 has a value of 4. Bit 7 has a value of 2. And bit 8 has a value of 1. If you do not remember this, you can just start by using different powers of 2 from right to left. For example, this is 2 to power 0. This is 2 to power 1. This is 2 to power 2. 2 to 3. 2 to 4. 2 to 5. 2 to 6. And 2 to 7. And if you're wondering why I start with 0, in computer world we always start counting from 0. We do not go for counting from 1. This is not in computer world. So just remember these values, and this is very important to work with different bits and an IP address. Okay, now how can I use these values? What is the use of this? Assuming that I have a binary value like this, 1, 0, 0, 0, 1, 1, 0, 1. How can I convert this into decimal using these values? That's easy. Wherever we have a 1, we use this value. Wherever we have a 0, we do not go for the value. So here I don't have a value, but here I have. Here this is 1, so I'm going to assign the value to this part. This is 1, so I'm going to assign this value. This is 0, I'm not going to assign any value. This is 0, again I'm not going to assign any value. The same happens here, and again this is 1, so I need to assign the value to this. So we have some values here. We have a 128. I add this to another value that we have here. We have a value of 8. I add this to this value. We have a value of 4. And I add this value to 1 here. So you can see that I assign the value of each bit to the bit corresponding to that place if it is 1. If that is 0, I'm not going to assign any value to that. So now I sum this up. 128 plus 8 plus 4 plus 1 becomes equals to, I guess, 141. So this is going to be 136, 140. Yes, that's 141. If I want to verify this, I can use calculator. So let's go for Windows calculator or Linux calculator based on the platform that you are using. I go for programmer mode, and here I type the values. You see that I can go for binary. Just press the binary here and start with this 1 0 0 0 1 1 0 1, and then go and click on decimal. By clicking the decimal, you can see that the value is 141. This is exactly what I have received from this conversion. Let me give you another example. Assuming that they give you this value 0 0 1 1 1 1 0 0. How can I convert this into decimal? Let me draw a line here. And now, this is 0. This is not going to receive any value. This one is 0 2. But this one is 1. So it is going to receive the value. We have a 32 here. This one is 1. So this is going to receive the value again. This is 16. This is 1, so this is going to receive the value. The same happens here, but these are 0, so they are not going to receive any value. Okay, let me write the values that I receive. I have 32 here. I add this to the 16. I add this to 8. And I add this to 4. These are the values that I received because those bits are 1. Now if I want to add this up, 32 and 16 are 48, then 56 and plus 4 equals to 60. Let me see the result in calculator and make sure that I have been right. So I have 00111100. You know that I should go to binary. Type 00111100, and if I click on decimal, you can see that the value is 60. So I have been correct in converting the binary into decimal. Now in next section, I want to show you the opposite. How can I convert from decimal to binary?